In this course, we will be going over the types of locomotion commonly used in VR and how to implement locomotion into our vertical slice. We'll begin with discussing some points that need to be considered when designing locomotion mechanics in VR and their effects on the player. We'll then talk about the common locomotion types as well as how the Unreal Engine VR template handles this mechanic. Adding on to this mechanic, we will create our own way of moving around the scene so that the end user can decide what works best for them. Then, we will spend time working with Oculus Guardian, recentering our view, and finishing off with the collection of the remaining assets needed for this learning path. Let's start off with an overview of locomotion in VR. A common problem some users experience in VR is motion sickness. Motion sickness, or simulation sickness, is much more common in virtual reality than in traditional gaming experiences, since our game camera is our player's head, and any motion our user sees will make them feel like they themselves are moving. There are a few important things that we can do to minimize this issue for our end users. Because we as developers are more comfortable in our VR experiences as we are more used to it and have a good idea of what to expect, it is important that we test regularly and often to see if we are potentially causing any unintended issues like simulation sickness for users who are less familiar with being inside of the headset. It is also highly recommended that you test your application with a variety of users to better ensure that motion sickness is minimized for as many different people as possible. Plus, the critique received from users outside of the development team is important to the overall success of the final project. Here are some general rules you should follow closely to avoid creating motion sickness for your users. Remember that in virtual reality, the camera is actually the view of the user. For this reason, avoid cinematic cameras or anything that moves the position or orientation of the point of view. This tends to be the primary way to cause motion sickness for your users in VR. Don't override or manipulate the field of view, or FOV. The value needs to match the physical geometry of the headset and lens. These should be automatically set through the device's SDK and internal configuration, but if there is a mismatch, the worlds will appear to warp when users turn their heads, leading to discomfort or nausea. Try to imagine looking around through a zoom or ultra-wide-angle lens and how disorienting it would feel. In conventional first-person games, the walking bob camera effect is a common way to mimic walking. But in VR, this effect overly exaggerates the movement, possibly causing motion sickness for users. Do not shake the camera when trying to relay an event to the user. If an explosion occurs next to a user, for example, a camera shake may make sense in non-VR games to recreate the sensation of movement, but in VR games, this artificial movement can trigger simulation sickness very quickly. Here are some additional tips to help you create experiences that minimize the chances of motion sickness for your end users. When you are designing worlds and levels for your VR experience, make sure to use dimmer lights and colors than you normally would in a traditional game. Strong and vibrant lighting in VR experiences can cause simulation sickness to occur more quickly. Avoid this by using cooler shades and dimmer lights than you normally would, which is something you'll need to test often to verify your project looks how you envisioned it. Overly bright scenes or strobing effects can be harmful for users with specific photosensitivities, and we need to be mindful of this. If, though, certain effects like this are required at points in your projects, perhaps give an option to a user to minimize the strength of the effect so that they can enjoy the experience without any discomfort. Avoid stairs and use elevators instead if you want to include spaces with elevation. When the user is moving quickly, especially up and down stairs, it could be very disorienting, because the real body of the user is not actually stepping on physical stairs. Think about that feeling when you're not quite at the bottom or top stair but think you are, and then you miss a step. This is the same effect we risk creating for our users by using stairs. Another point would be acceleration. Acceleration of the user should be instantaneous and not gradual. This is because human movement works that way. You decide to take a step forward and immediately move at that speed. Your brain doesn't gradually accelerate your legs until you begin moving forward, so any movement you have in VR should match human movement as much as possible. Speed can be variable based on user input, but the user should have precise control over the speed. Do not use depth of field or motion blur post-process effects, because they greatly affect what the user sees and can generate simulation sickness because this interferes with how our eyes behave. Plus, they are expensive effects anyway. VR is still a young medium, and there is a lot to learn about how people will respond to different mechanics and effects. There have been exceptions to these rules that worked successfully. The point is to be aware of them and make sure you understand the rules before you encroach onto them or even break them. Next, let's discuss different locomotion types and learn how the Unreal Engine virtual reality template handles locomotion.